day, Doctor. We are from Group 3, Section 6, and today we are going to present about our structural work for our IDP project with the title of Cadangan Membina dan Menyiapkan Asrama Sekolah Sukan Terengganu, Kong Badat, Kuala Terengganu, Terengganu Darul Iman. The construction site is located at Kong Badat, Kuala Terengganu, and is only 3.3 km far from Sultan Mahmud Airport. The proposed site of the project is about 60 meters square, which include the construction of building and infrastructure, such as parking area and the road and drainage system. The overall dimension of the building is 36,125 mm in length and 10,875 mm width and 16,879 mm of height. And the building consists of 4 levels. Ground level is for warrant, and first floor to third floor are provided for student usage. And there are 2 staircases located at both ends of building. Here is the side view of building.
Good day, I'm Huang Chai-Ching and I will present on the design specifications and pile bearing capacity. I'll start with pile bearing capacity. From TECLA, the total column load that we obtained is 35,485.6 kilonewton. After taking 50% increment, the average load for one column is 1,407.2 kilonewton. Consider that it requires 4 piles, therefore the initial pile capacity is 400 kilonewton. Based on a manufacturing standard, the effective diameter of spun pile is 450 mm. This is our bore log. As you can see, the hard strata is as deep as 21 meter. Hence, the pile length that we consider is 20 meter. From the calculation, the allowable bearing capacity and the maximum actual working load is 1,491.69 kilonewton and the recommended actual working load by JKR is 904.06 kilonewton. Next is the design specifications. These are the design specifications including variable action, permanent action, material and characteristic strength and durability that were decided as according to Eurocode. Now here is the key plan for first floor. Taking first floor as an example, this is how we locate our beam and column, where the size of main beam is 200 times 500 mm and secondary beam is 200 times 350 mm. The column is 700 times 700 and the slab thickness is equal to 150 mm. The next picture indicates the height per level, where from the stump to the first floor is 2 meter and the height for each floor is 3.2 meter and from roof to upper roof is 1.5 meter. That's all from me. Thank you.
Hi, my name is Muhammad Naim bin Aziz and I will be presenting on the total cost for the cadangan membina dan menyiapkan asrama sekolah sukan Terengganu. This is the DQ for the structure. Based on the calculation, we find out that the total cost for the lower floor finish level is 250,000 ringgit, while the upper floor construction is 300,000 ringgit. This includes the supply labor, material, transport, tools, and everything necessary to construct and complete the work. For the material itself, we find out that the total cost for the column is 201,000. For the beam is 138,000, and for the slab is 197,000. Next is about the roof construction. Based on the calculation, we find out that the total cost for the roof construction is 139,000 ringgit. The others are the detail for the whole construction, which include the staircase, step, wall, railing, and others. After summarize all the detail, we find out that the total cost for the building itself is 1,081,031 ringgit and 50 cents. For the piling work, we use a 450 millimeter in diameter spun pile with a depth of 20 meter driven into the soil. So we use an initial of 12 meter 12 meter initial pile, and then another 6 meter for the extension, and another 3 meter. So there is a 1 meter cut off, and after calculation and summarize all the detail, we find out the total cost for the piling work is 112,461 ringgit and 11 cent. So for the whole construction, we can summarize that the total cost for the whole construction is 1,609,627 ringgit and 15 cent.
This is the DECLA modeling of our project, which include beam, column, slab, and foundation. And we can see here is the ground floor of our building. This is first floor, second floor, third floor. This is the roof floor, and this is the upper roof beam. And the last is the pile cap and the piling system. After develop the structural member, we input the loading which include the permanent load such as finishes and services, and also the variable load. Then we can analyze and get the output of the DECLA. For example, this is the beam detailing, column detailing, slab detailing, and also the foundation layout and foundation detailing. That's all from me.
We made comparison from the TECLA analysis and manual calculation for slab, beam, column, and foundation. From slab 9 to 10 and D to H, area required for bottom X from TECLA is 53 millimeters square per meter, while manual calculations 57.47 millimeters square per meter. From bottom Y, from TECLA 79 millimeters square per meter, while for manual calculation 38.28 millimeters square per meter. For top X, from TECLA 176 millimeters square per meter, while from manual 77.43 millimeters square per meter. And from top Y, area required is 119 millimeters square per meter from TECLA and 50.38 millimeters square per meter for manual calculation. Next is the analysis of beam. Beam 9 and A to H. The bending moment from TECLA is 37.2 kilonewton meter, while from manual calculation is 56.1 kilonewton meter. The area required for the steel from TECLA is 197 kilonewton per meter, while from manual calculation is 313 kilonewton per meter. Next is column. The column analyzed is 9H. The longitudinal bars from TECLA is 2,412 millimeters square, while for manual calculation is 1,710 millimeters square. Last but not least is foundation 9H. The moment at x-axis from TECLA is 118.65 kilonewton meter, while from manual calculation is 777.38 kilonewton meter. While for moment at y-axis is 113.14 kilonewton meter from TECLA and 600.3 kilonewton meter from manual calculation. While the longitudinal bar area from TECLA is 529 millimeters square per meter, while from manual calculation is 1,423 millimeters square per meter. And the transverse bar area for TECLA is 494 millimeters square per meter, while from manual calculation 1,000 112 millimeters square per meter. So overall, from the Tekla and the manual calculation, there is a big difference from all the value.